All right, so today is day 2 of 11.3. And so our essential question, I think, is the same as the last one, but how do I find the probability of independent and dependent events?
And as you can see right away here, we have an example. We are going to save example 1 for class. So we are going to now go to the next page already. Example number 2, which is right here. So let's go over this. In many cases involving random selection, events are independent when there is replacement.
Okay, so it doesn't matter as long as we put the stuff back in.
Right.
Got it.
And dependent when there is not replacement.
So it depends on it if we're taking something away.
And you don't put it back in.
Put it back in. Got it.
A standard deck of cards contains 4 suits of 13 cards each. The face cards, this is important, are jacks, queens, and kings.
Okay.
And there are 52 cards in a deck.
Yes, I'll just write that off to the side.
Oh
boy.
Oh boy.
I forgot I last highlighted.
We have highlight.
When you skip the first page, I forget.
Sorry.
52 total cards. Got it.
So let's go on to example number 2.
Okay.
2 cards are drawn from a deck of 52. Determine whether the events are independent or dependent and find the probability.
Okay.
So part A, we are selecting 2 hearts when the first heart is replaced.
It is replaced. So this is, oh boy, what is it doing? It is replaced.
Right.
So it's independent.
Independent.
Doesn't matter.
Right. So we should write independent. That is definitely independent. Because it says it's replaced.
Got it.
So we're going to find 2 different probabilities and multiply them together. So the probability of getting a heart, first of all. So we know there are 13 hearts in a deck of cards. And if we select a heart, take it out, and put it back in, there are still 13 hearts in the deck.
And there are still 52 total
cards in the deck.
Because we put it back in.
Exactly. And so now if we multiply those, 13 times 13 is 169. And 52 times 52 is 2764.
Okay.
And if we reduce that, because you always have to reduce, you get 1 over 16.
Oh, that one's a nice one.
Pretty nice, easy. Okay.
All right.
Part B, the probability of selecting 2 hearts. So again, up here, I think we did hearts.
So we'll have 2 fractions we're multiplying.
Selecting 2 hearts when the first card is not replaced.
Not replaced this time.
That's going to be dependent.
Depends on what we take out, so don't put it back in.
Right. So
at the beginning, we have 13 hearts.
Out of 52.
Have a total of 52.
Right.
We take 1 out.
Right. We no longer have 13.
We only have 12 left.
Over.
And we took 1 out, so we're only left with 51.
And if you multiply 13 times 12, you get 156. And if you multiply 52 times 51, you get 2652.
Does that reduce nicely?
That is going to reduce, and that reduces to 1 over 17.
Oh, nice.
And there we go.
All right.
Now part C, a queen is drawn.
Okay.
Is not replaced, and then a king is drawn. Okay? So how many queens are in a deck of cards?
There are 4.
Out of?
52.
Right. Oh, and I forgot. I'm kind of jumping ahead. If it's not replaced, then that is called dependent.
Right. Sorry.
So we got to remember to write that down. If it's not replaced, it's dependent. So we're going to multiply that by drawing a king. How many kings are there in a deck of cards?
4.
4.
Oops.
But
we already took 1 out.
We already took a card out.
Back in, so now there's only 51.
But the reason why the 4 is not a 3
is because we didn't take a king out.
We didn't take
a queen out.
Right. We took a queen out and then a king.
Gotcha. I'm just going to clean this up. It's bugging me.
Okay. So 4 times 4 is 16, and 52 times 51 is 2652. And if we reduce that, we will get 4 over 663.
All right. Oops.
Oh, we're going to fix that.
Sorry about that. Okay, so that's pretty easy enough.
Yeah.
You just got to think, if we're replacing it, then we use the same number as we did up here in example 1. If we don't replace it, then it usually goes down by 1.
Correct. Yeah.
Okay.
Next page. A bag contains 10 beads. 2 black, 3 white, and 5 red. That adds up to 10.
Okay.
A bead is selected at random. Determine whether the events are independent or dependent. Find the probability.
Okay.
So what's the probability of selecting a white bead, replacing it, and then selecting a red bead?
All right, so this one's independent because
You're
we're
replacing
replacing it.
Exactly.
All right, so we start with our first fraction. There are 10 total beads.
And how many are white?
Take out a white, there are 3.
Right.
We replace it, so there's still 10 beads to choose from again.
Yep.
And now we're taking out a red, which there
Which
are
is 5. And now we multiply straight across.
15 times 100,
Yep.
or 15 over 100.
Which is 3 over 20.
Nice.
And that's it.
All right.
So let's go down to the next one. What's the probability of selecting a white bead, not replacing it, and then selecting a red bead?
So this
so if
one's
you-
dependent.
Right, when you not replace it, it's dependent. So again, we should go back up and look.
Yes, we want
How many white beads are there? There
It's
are
3.
3. Okay, so we'll write 3 over 10.
We don't replace it, so
Right.
now we only have 9 to choose
left, so
from.
we better go up
And
and
we're
look
looking
how
for
many red ones there are.
5.
There are 5. So then we're going to write 5 over 9.
So we get 15 over 90.
Yep, which reduces to 1 over 6.
Nice.
And another one. Selecting 3 non-red
Got it.
beads without replacement. So if we're not replacing it, what did we say that is? Dependent. So we should write dependent. So we know how many beads are there again?
There's 10.
10, that's our denominator. So let's go back up and look. How many of them are not red? 2
2 and
plus
3
3
is
is
5.
5. Okay, so 5 are not red. And we're not putting it back. So times 4 over 9.
Right. Because we're not putting back one of the non-red ones, so it's 4 this time.
And then we're doing a third one.
We're not
so
replacing it, so we're down to 8.
times 3 over
and
8.
times 3.
Exactly. And if you multiply all those together, you're going to get 60 over 720, which initially reduces to 6 over 72, like Miss Boyd did, and again reduces to 1 over 12.
Nice.
That's it.
Oh, this is an easy lesson.
Yeah.
Good.
Next page.
Oh,
Video
good
questions. So one card is drawn from a deck. Find the probability of selecting a face card. Face cards are jacks, queens, or kings. And there are 4 jacks, 4 queens, and 4 kings in a deck of cards.
So figure it out.
Then 2 cards are drawn from a deck. Find the probability of selecting 2 kings when the first card is not replaced.
Okay.
See you tomorrow.
Bye.